All right, assignment 6-3. Got my math t-shirt on. I'm ready to go. This is about integration by parts. It's a BC topic. I think the more we practice, it won't be so long and so challenging. So, by parts, we have two parts. One is usually an algebraic part, and one is usually trigonometry or an exponential or a logarithm. And so in this situation, we're going to let x equal u. We're going to take the derivative of that. The derivative of x is 1, but it needs a dx. dv is going to be sine x, and then we're going to integrate that for what v is. So the integration of sine is cosine. Then this is the formula we're going to follow. I'm going to put it up here. U times v subtract v du. And if we practice that, we'll remember it. It's got to be a good rule follower. I'm sorry about the camera going in and out. So u v v du. So we have x times cosine x. And then the integration of cosine is just sine. So it's going to be subtract sine, and then don't forget to go plus c. I made a mistake. Where did I make a mistake? Oh, the integration of sine is negative cosine. There it is. So this should really be negative x cosine x. And this, should be negative cosine. So a negative times a negative makes this positive. It matters. And here we go. Number 2. Integrate x times cosine 2x. Press pause and see if you can set up these 4 things. And then we'll go from there. So try those 4 things and then press play. So the hook comes from inside the trig, which is 2, and then what it was over what it becomes. And then you can ignore this hook. And then it starts with 1/2. The antiderivative of cosine is positive sine. I'm positive. And now you have that. Did you get that on your own? Next, we're going to follow this formula. So it's u times v, integrate v du. Press pause and see if you can set this up. And now we have one more step to do. So the nice thing about the beginning of the rule is that it's done. Here, the 1/2 we can write in front. The hook should be 2, so we need another 1/2 to undo that 1/2. And then the antiderivative rule for sine is negative cosine. I can learn from my mistakes. Oops, no dx. And if we wanted to clean it up just a little bit, so a negative times a negative is positive. This is 1/4. And then plus c. All right. It's already getting better, right? Or no? Let's keep practicing. Integrate 4x e to the 2x. So again, I'm going to set it up. I'd like you to press pause and see if you can set it up. Can you find these values that we need for the formula? So 4x, the derivative is 4 and needs a dx. E to the 2x will be dv. The integration of e is e, but the hook is 2, so we need a 1/2 and then just copy. All right, C. Next, follow the rule. Press pause and see if you can set it up. So there's the setup. 4 times a half is 2x. 4 times a half is negative 2. I'm going to put that in front. The hook comes from the exponent. The derivative of 2x is 2. That's the hook I need in front for the chain rule. To undo that, I need a 1/2. So we have 2x, e to the 2x. 2 times a half is 1. And then it's just e to the 2x. Plus c. Number 4. I hope I have room. We're integrating x squared e to the x, x cubed by parts. So these are the parts I'm going to do way off here. U, du, dv, v. Can you do that? And then we'll come back here and use it in the formula. So that's x squared 2x dx. E to the x squared, x cubed. E to the x cubed. You know what? At this point, I realize I don't have an integration rule for this because I need an x squared in front to work. But wait a second, I already have an x squared in front. This now causes me pause that I can't complete this. I can't integrate this. I set it up and realize, wait a second, go back. Let's go simple. Where does the hook come from? X cubed. The derivative of that is 3x squared. What was it before? A 1. And what did it become? A 3. And now we can unhook and then follow the rules, which is 1/3 and copy. No integration by parts. So should I assume that every time is going to be integration by parts, even if it kind of looks like it? And it's okay to start it and realize something's up here. I can't complete this. Go back and look at it again and go, oh, I'm going to go a different direction. Number 5. I'm going to write this calculus friendly. The derivative of negative x, as I learn my mistake hopefully, is negative 1. That's unlike terms with in front, so I can't go in that direction. So I'm going to go in the direction of integration by parts. I want you to press pause and see if you can fill this out. And then press play. And then come back here and the formula. Press pause again and fill this in with the formula. Or have you memorized it yet? The best way to memorize something is to practice it, not by doing a flashcard and trying to stare at it. You actually practice the formula enough, you'll remember it. All right, I'm going to clean this up a little. So a negative times a negative is positive. So there it's cleaned up. The hook should be negative 1, so I do need a negative in here, but I clean it up first and then realize the hook I need and how to undo that hook. And then I can do the antiderivative rule. So it is going to be subtracting. Then this can go, and the rule for E is you copy it, and then plus C. Number is that 5. I'm always double checking, make sure I didn't lead you astray. Good. Number 6. So we don't have a rule for ln x. We're going to do this by parts And how we're going to think of it is it's 1 times ln x. Now in this situation, ln x has to be u because we don't have an antiderivative rule for ln x. That's what we're doing right now. So this has to be ln x, which means dv is 1, and the antiderivative of 1 is x. And the derivative here is 1 over x dx. So we don't have a direction. So when it's a logarithm, then that's what u equals. Otherwise, it's what the algebra is what u would equal. All right. So the formula, u times v, subtract v times u, v times du. Clean this up. X times 1 over x is just 1. And then once it's cleaned up, then look to see what the antiderivative rule is. And that antiderivative is just x. So the antiderivative of ln x is x ln x subtract 1. X ln x subtract x plus c. So now we have a rule from the integration by parts. Number 7. All right, write it down. Can you integrate that? So first is a setup. So press pause and set it up. In fact, before I do that, I'm going to definitely write this calculus friendly. So you're going to let that equal ln x. That means du is 1 over x. Dv is x to the negative 2, and then integrate it. You add 1 to the exponent and divide by that exponent for the integration of it. Now the rule. So u times v. So it's going to be negative, and instead of x to the negative 1, I just wrote it as a fraction. You could also write it this way. Both are the same thing. It's good to know they're both the same thing, especially for multiple choice, to know that you could match up if you had to. Subtract. Now I'm going to integrate uv, or v du, I mean. Now I'm going to clean this up a little bit. Oops, I need a dx there. So there is v du, and so I'm going to recognize that this is, first of all, a negative times a negative is positive, and this is 1 over x. So 1 over x is 1 over x squared. So I'm going to write it as x to the negative 2. And then I'm going to add 1 to the exponent. Oops, that's negative 1. And divide plus c. And yes, the positive negative would make that negative, or 1 over x. And that's it. You did it. All right, we're getting better with practice, right? Like, you know the formula pretty good by now. It's just practicing with some calculus rules. So here we go. All right. So already when looking at it, my spider sense, that I have none, went off here. The derivative of ln x is 1 over x. So I'm going to write this as 1 over x ln x squared dx. And no, the hook comes from here. So the derivative of ln x is 1 over x. And then it's just the power rule, where I add 1 to the exponent and divide plus c. So the more you practice, see, integration is different than derivatives as such. Derivative, you just know the rule, follow the rule. The thinking part isn't very strong. For integration, there's a lot of things that look similar, and we have to be able to think through the different options they could be. And the more you practice, the more you recognize certain things and go in the right direction. But it only happens with practice. Number 9. I'm telling you, integration is like solving a puzzle, and derivatives is just plugging it into a machine. And so some just want to plug it in, but some like the idea of integrating the puzzle part. of can you figure it out. And if you like the puzzle part, then you know you're becoming a mathematician. That's scary, isn't it? All right, so arc tangent x, we don't have an antiderivative rule. We're going to think of this as times 1. So we're going to let u equal arc tangent x, because if we could do the antiderivative of that, then we would just write the answer down. Okay, then the derivative of that is a fraction. It's 1 over 1 plus x squared. That's the rule for the for the derivative of arctangent. And then integrate 1 and it's x. Oh, we need a dx here. So now we follow the rule. So that's uv minus v du. I'm going to clean this up and then look what direction I'm going to go. Oops, I'm going to write it this way. I already know what direction I'm going to go. So, x times this, that's in the numerator. So, I said when it's a fraction, it could be a few things, but the easiest thing to look at is if it's a logarithm. And so what's the derivative of the denominator? Does it match the numerator? It's a logarithm then. And the derivative here is 2x, which means I need a 1/2 to undo the 2, so it stays the same. So we have x times arctangent x. We have 1/2, and then it's a logarithm, and what you see in the denominator goes inside the logarithm. Number 10. So, I mean, the hook comes from here, so the derivative of x is 1. They're not like terms. I think this is going to be a double whammy. Yeah. Okay, so this is going to be a longer question. We can do this. So u is x squared, d and dv is cosine x. The derivative of u is 2x dx. The antiderivative of dv is sine x. And then I come back here and I fill it in. So the rule is u times v, subtract, integrate, v du. All right. I still can't integrate this because the hook, this is what I saw ahead of time, it's not like terms with this hook. So again, I got to do integration by parts a second time. I'm okay. I can do it. So I'm going to call this U2, which is a great band from the 80s, which will be 2x. The derivative of that is 2. I'm going to call this dv. The second part is going to be sine x. And the antiderivative of that is negative cosine x dx. Come back here again. We have x squared sine x minus u times v. So a negative times a negative will make this positive. And that's 2x cosine x. And then subtract v du. So that's negative cosine again. So I'll clean that up at the second. And then we have 2 dx. All right. So let's clean this up a little. I have x squared sine x. I have 2x cosine x. And negative times a negative is positive. And we're going to put that 2 in front too. That's a property of integration, so that constant can go in front. And now what's the antiderivative rule of cosine? That's sine. And that's it. You have it. So it's not like an hour. I've done problems that have taken an hour. It's just the work involved in practicing so you feel comfortable with it. And don't forget plus c at the end. Just double checking. Sometimes, I check and have to go back. But it's perfect. Nice one is that one. Number 11. All right, write down the question. So where does the hook come from? Here, the derivative of 2x is 2. It's off by 2 degrees. This is what makes me think it's 2 steps. See, 2x, the derivative is 2. x squared. That's off by 2 degrees, which means it's probably going to be multi-step in terms of integration by parts. But the better we get at it, right, we can then get through this easier. So the derivative of 2x is 2, so I need a 1/2 e to the 2x, and then we just start. U times v subtract v du. And that's a dx. Keep forgetting the dx at the end. What the hey? All right. And then I'm going to multiply this through. So I got x squared over 2 e to the 2x. I got 2 times 1/2. That's 1. And it's e to the 2x dx. All right. Oops, I need an x in front. This, again, is integration by parts. So I'm going to come back here. I'm going to call it with a little 2. So we got x with a little 2. That's e to the 2x. We just did that one. So the integration here is 1/2 e to the 2x. And I'm going to do it again. So we have x squared over 2 e to the 2x minus u times v subtract v times du. I'm going to clean this up. So the 1/2 I'm going to put in front. I'm going to leave a little space. The hook should be 2. So I need a 1/2 to undo that. That 1/2 that's already there does not count. We need another 1/2. So we have x squared over 2 e to the 2x. X over 2 e to the 2x. 1/4. And then e to the 2x plus c. That's a lot of e to the 2x's. Double check. Goodness. Having a good morning. Number 12. I hope you're having a good time doing this, that you're actually feeling a good time in math is understanding it, not being lost, not being afraid to do the work that you need to do. All right. When I look at number 12, look at the denominator. The derivative of this is 2x, so I need a 1/2 in front. This is 1/2 ln 1 plus x squared from 0 to 1. We can factor out the 1/2, plug in 1, and it's ln 2. Subtract, plug in 0, and it's ln 1. Well, ln 1 is just 0. So this is just 1/2 ln 2. For fun, that could also be written like this, because a logarithm, a property, that could be the exponent on 2. Just different ways that the AP exam could trip you up. But not you. You got this. Number 13. We're integrating from -3 to -1. All right. This already feels like arc sine, just because of the square root and subtracting and so on. I need to clean this up, and I need to complete the square. So, do I have that in me? So, we're going to start with -x squared minus 6x plus 7. We're going to just make sure it's done that way properly. Then, this work is just going to be in the cleanup part. I'm going to factor out a -1 just from the x squared and the 6. To be able to complete the square, oops, I'm going to leave a little space there actually. Plus 7. I didn't mean to close that parentheses. To factor out, to complete the square, a, the part with x squared needs to be a positive value. So we factor out the negative, so it is positive. To complete the square, divide by 2, 3, square it, 9. And then we're also going to subtract 9 so it stays the same. So we're like right there. Did I forget a dx? I always keep saying, don't do that. All right. Now we're going to complete the square. And I'm going to put it in the right order for arc sine. So -9 plus 7 is 2. Oh, wait a second. I made a little mistake. So notice I put plus 9 minus 9. This is positive 9. But if I go negative times 9, it's actually a -9 if I distribute. So I did put a 9 there, but when you distribute with the negative, it's actually negative 9. So this actually has to be plus 9, so it stays the same. So it's actually negative 9 plus 9, which is 0, which means these are the same. That's why I look back at the answer key, in case I make a mistake. Now I'm going to rearrange it. 9 plus 7 is 16. And then to complete the square is x plus 3 squared. Now we're there. A is the square root of 16. U is the square root of x plus 3 squared, which is u plus 3. And now I got the rule, and then I need room to plug in at the end. So the rule is arcsine u over a. Sorry, that's 4 over u plus 3 from negative 3 to negative 1. Sorry, that's x plus 3. Why did I put u plus 3? All right, from negative 3 to negative 1. Now, I'm going to plug in negative 1 first. So negative 1 plus 3 is 2. 4 divided by 2 is 2. What did I do wrong? Oh, it's the other way around. It's u divided by a. Arcsine can't be 2. That's not the domain restriction, so I know I made a mistake. So it is x plus 3 on top and 4 on the bottom. I think I actually said u over a. U over a. But I didn't write down what I said. Anyways, plug negative 1 in. Negative 1 plus 3 is 2 over 4. That's 1/2. That I do have an angle for. Subtract arcsine. Plug in negative 3. Negative 3 plus 3 is 0 over 4, which is 0. So at what angle is the y value on the unit circle 1/2? That's at pi over 6. And then the value of where at angle 0, the y value is 0. So this answer is just pi over 6. Number 14. I think I'm going to go up to number 16, maybe number 19, and then I'll do a second video. All right, number 14, 0 to 1, x e to the 3x dx. Again, where does the hook come from? The derivative of 3x is 3x. So I need a 1/3. So it's just 1/3, and the rule for e is to copy it. And no plus c. Some of you, when you have a definite integral, still want to go plus c. No plus c. We have bounds, and then we plug in those bounds. So first the 1, subtract, and then the 0. When you plug in 0, it's just 1/3, and you have your answer. Number 15. What did I do wrong? I did something wrong. I did. Ignore this. Let's try it again. And like what I say and what I do, I got to match it up, right, with my brain. So it's okay. This is what we do. If you don't make mistakes, you're not a mathematician either. So, and you are a mathematician. I believe it. The derivative of 3x is 3x. This is x. Sorry. The derivative of 3x is 3. And this is x. They're not like terms. So I have to do integration by parts. So now the derivative of this is 3, so I need a 1/3. Now I plug it into the formula. So it's u times v, subtract v times du. Clean it up. The 1/3 I'll bring in front and leave a little space. The derivative of 3x is 3, so we need a 1/3 to undo it, to do the anti-chain rule. And this leaves you with 1/9 plus c. All right, I'm going to stop there. Boom, boom, boom. Where am I going to stop? Right there. Mr. G Math over and out.